So let's have a test of this logic analyzer. So I need software first, but anyway, it's switching to menu mode. So I'm going to plug in power. Select game. So it's blue. I guess Windows is installing drivers. Oh yeah, after installation it turned green. Yeah, so this program comes with a digital discovery. It's called waveforms. Something interesting is that when you start, that's also a problem. It's really hard to get a good trigger. Anyway, you can see here, this is the bus, the address bus. You can see it goes through all possible addresses up to 256. And on the data, I will see that it stores 0. So it seems like it's an initialization routine where it writes 0 to memory. That's the first thing it does, or something. See 0 there. And then I found a fault in my drawing, like here. If this is, I think it's a bug in KiCad also, by the way. Now I can see both at the same time. I don't know what's going on here. So I turn off pads back. There, you can see it starts at. Okay, so now I can see. Now I see pads front and see pin 1 here. But when I look online, see that pin 1 is over here. So I couldn't understand why this one is over here. This one which is not used, but that's okay. It's just I have it incorrectly. Oh, by the way, I usually don't download like nightly builds, but this was a fix from yesterday. So where you could before you couldn't see the correct text on the front and the back. So because some silk screen or something was written on the wrong side. So when you switch these pads front and back, it doesn't show the correct one. So this is nightly build from yesterday, and it was fixed yesterday. So that's really cool. Look, there's like a dinosaur there. Or where is it? Is it a crane or is it a dinosaur? Weird. Let's try with this one. See if we can see 50 Hertz or 100 Hertz or 25 Hertz, whatever, by making a routine which calls vsync, waits for it, changes or alternates one of the outputs, and then loops. For this project I'm going to just see if I can do a 50 Hz signal and then pick it up on the logic analyzer. So for that we'll use assembly code. I will take the hello world, strip away everything almost, and then I will use something called wait vsync to get the 50 Hz screen refresh. So yeah, so that's a routine which is in the G7000 BIOS. So I'm looking at the code here, and okay, so I've taken hello world basically and just copied it to new file, make jump to start when it gets this far, like this. We don't need hello string anymore. Well, we can keep it. You know what? Let's keep it. And after that, we're going to do the 50 Hertz routine. But we're not going to stop. We're going to just loop forever. 50 Hertz. So I'm going to keep the hello world because I know if I can see hello world on the screen, I know there's signs of life. Yeah. You can do some reads from memory and then pick it up every 50 seconds. Or you can do something else. like flip something on the port. Here you can see we have several ports. We have a bus port, we have a port 2, we have port 1. We don't have a port 0, but that's okay. So I was thinking, okay, this one goes up and is currently not used, the CS. And that's P14, so that's bit 4 from 0 to 7. It's bit 4. So let's try toggle that one. So you can't do this ORing or soaring or anding directly on the port. You can only do it directly on the accumulator. So that's what we're gonna do. So we're gonna copy it, and it looks like we maybe should copy move also if you are really lazy. And today I feel really lazy, so yeah, so here we go. We don't need a loop actually. So I think it's gonna be 1 0, so let's just explain what that is. 0 0 0 0 0 0 0. So that's the pattern we want into R3. The reason I want that one is because this is bit number 4 basically. So yeah, we're gonna be really smart here. We're not gonna mask anything. I think we can do soaring XOR. We got OR at least. XOR, wow. Data in the accumulator exclusive OR with an immediate specified mask. Great, so we already have a mask. But let's try. So first we dump it into A, P1 into A. And then we're gonna use XOR mask. And here's the thing with XOR. It's the binary, 4-bit binary. And then we sort it with 0, 1, 0, 0. Let's make that an assumption. So what's the answer? So we can toggle. That's great. I think it's great. SOAR A with R3 now. Sorry, R3. Then we're only going to change P4. That's what I think, at least. And then, finally, we're going to put it back on A. So this will alternate pin 4, I think, with the theory I just explained. So let's save it. Press F5, compile it. And it compiles, or it assembles, sorry, compilers for C and such. Well, there's an error. Now where is that error? 72. So it doesn't like this. Why doesn't it like this? Is it, no, it's not small characters. I don't think that's it. Because, okay, so it wants a literate. Okay, then we don't need R3 actually. That's great. We can just say, yeah, because now I see it's a literate it doesn't want to register. Okay, so let's remove that. So that's great. Let's try it again. Press F5. Let's see. Still an error at 71. Unknown opcode. I'm looking at this. I don't know why this is different, but it's XRL. How silly. Silly of me. Sorry about that. Let's try it again. It's got 2 passes, no errors. We have 50 Hertz of gray. So, let's go. So it doesn't repeat after 1000. So I can show you how it works. Transferring with the RAM card, downloading using the download program. Finished. When it's finished, flip the switch. Reset. Actually it reset by itself now, I don't know why. Hello world. So that's working, and now my program is also doing that 50 Hz thing, so I hope I can reset, press another number, still starts again. So we can hold it and reset there. Okay, soldering pin 11 there, so just taped it down for a measure. So yeah, so there you go, so let's try it. Okay, I have Hello World running now, and yeah, so let's see if we can pick up something. But I don't see that the 1550 Hertz here, so what's going on? Wah, 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 wah. I connected it incorrectly. I connected it to one that has a line on it. It's the one lonely island over there. So, okay, be right back. Oh my god. Yeah, so it seems to be working actually, if you look here. Why it has a break in the middle, I don't know, but you can see that it's periodic, but it's only 20 microseconds. Well, we don't have this call here, so let's put that in. What was that call again? Wait for sync, which is up here. Bring that down there. This, save it, F5, run, no gotchas. Let's do it again. So here we are again, let's try it again. Not what I was looking for, but hey! Look at that! So now it's not a fast code anymore. Now it's like brrr, and then it waits. So let's get out. So I figured out that if I hold control I can scroll much faster, but right now I'm holding the camera. Oh, look, we can't get the whole thing in the buffer, so we can increase the buffer over here. Let's see, let's take 500k. Run it again. Over there, single. There, look. So let's see what kind of frequency we have here. Why doesn't this work? Like, I can double click maybe. Is it just me? I can't see it. There, 1994. So that 20 milliseconds, yeah, cool. That's 50 Hertz. Well, actually, it's 25 Hertz because this frequency is divided by 2. You see, we just only change the direction of the signal. So that's really something. If you see here, you can see it says 1994. So looking back at the code, we see we started with writing hello world, and there's the loop writing the actual hello world. And down here 50 Hertz, wait for VSync, and then it waits like 20 milliseconds, or whatever is left of 20 milliseconds. It dumps whatever's on port 1 into A. We can actually do that only once here, I think. Anyway. And then it changes the state of pin 4 on port 1. And it puts it back again, writes it out again on the port. So, and I don't think this accesses the external bus. It's all happening inside the microcontroller, so you can't see any bus activity. But what we can see is that this program is written in external room, so I suppose you could see all of these instructions. Maybe you can do that for the end of this video. So that's one task, and the reason why I'm doing this is because I want to use this pin 4 on port 1 as the serial output by bit banging it, because the Atmega or Arduino has an RxD input serial port UART input, so then I don't have to write a protocol for it. So I just realized that people might not follow me because it's a very detailed process. And in here we have this processor, and we were changing P14, which is a port. So this is one of 3 ports. We have port 2, port 1, and then a bus. Anyhow, this is the last remaining bit of the code, which says hello world, and then we have the instructions. 8427, 39 and 10. Thought I was going to show you this in the code. There you have 27, 84, and 39, and then 10. You can also notice that we have 2B here, and then it ends up on the address, which is on the top, so 2B here first, and then 2B, and then it replies with 10. So why is this happening? Well, that's because we have 2 address latches here. So first, we see on the data bus that the address is latched in, and then the address latch is now put into the room, and back onto the bus again comes the data. So first address, and then you see the data. So yeah, so that's what you see here. 2B 10, 2C 39. Let's see, 2C 39. So that's correct. That's what I wanted to show you. So, and another thing you can see when this output is changing, the pin 4 on port 1 that I was talking about, that's after 39. And the way I found out that was to go back to the PDF here for assembly language reference manual. You see out L, which is in the code, the last bit, which puts accumulator out on P1. That's why it's changing, right? It starts with 3, and then it ends with 1001, which is 9, so 39. Sorry for not sounding more enthusiastic, because I've recorded this so many times, so it's like, yeah, hopefully I can be using this OBS now. So yeah, thank you very much for watching. I thought that was I hope it was interesting for you, and bye bye.